Okay, so we're looking at our ISTEP sheet. Any questions? All right, number 4 with the fractions. What I would do first is distribute that 4 through. So I distribute the 4, but when I distributed the 4 and the 6 had a common factor of 2, so I took out a factor of 2. So that left me with 2 times 23 over 3, which is 46 over 3. And then 2 times 5 over 3, which is 10 over 3. And then I moved the 1 to the right side of the equation. And then I was like, I don't want to deal with these fractions anymore. If I multiply by 3, that gets rid of all of my denominators. So I got rid of all my denominators by multiplying by 3. Don't forget that if you do that, you have to multiply that negative 104 by 3 as well. You can't just multiply the 2 on the left side. You also have to multiply the right side by it. Then it was a very simple looking equation, minus 10 divided by 4, m equals negative 7. Any other questions on the first 4? Okay, I'm going to start scrolling down. Now I have 5, 6, 7, and 8. 5 and 6 say write the slope-intercept form of the equation of each line. You need to get y by itself for those. So for 5 and 6, I minus my x term, so it was 7x, I minus from both sides. And then I divided by whatever the coefficient in front of y was. So I divided by negative 4. Don't forget that if you have a negative divided by a negative, it becomes a positive. And then I would like us to leave things in fractions. It's going to be easier to graph if it's in a fraction. If you did it in decimals, that is fine, but in the future, let's leave it as a fraction. Any questions on those first 2? Okay, the second 2 I know is where we kind of could get a little stumped. This one is I give you a point and I give you a slope. I want you to use the point slope form in order to solve this, which I have highlighted in yellow. Y minus y1 equals mx minus x1. Plug your slope in for your m, plug your x and y, your points in for your x1 and y1, and then you can solve. So a lot of us just forget point slope form when you're not like in the depths of algebra because you don't really use it otherwise. But I think that's the easiest way if I give you a slope and then I give you a point to solve. Now, if you see in the purple I wrote and then I circled it in the green highlighter, that's another method and it's also correct. Some teachers teach you to just use slope-intercept form and then find b. If that's the case, you can plug your slope in for m and then your points in for x and y. And then once you find a b, then we'll just put it in the form of y equals mx plus b. Sometimes I mess that method up, so I like to do the point slope form. I think that that is a little bit less mistake worthy for me at least. And then same thing for number 8. Any questions or anything I need to talk more about on this one? I'll leave it up for a second if you're still looking at it. All right, should I jump to the back? All right. Wait. No? Oh, I thought I heard wait. Okay, on the back side, you needed to find the slope, and then we needed to find the equation of the line. So I saw some of us just at the slope. Make sure you also find the equation of the line. So I used the 2 points to do my slope. Remember, slope is y's over x's. So it's rise, or your vertical change, over run, which is your horizontal change. And I wrote that in purple too, y2 minus y1 over x2 minus x1 in case you forgot. Once you find the slope, then we need to plug it in. I plugged it into point slope. You could have plugged it into slope intercept. That is fine either way. And once we plug it in, then we will solve for y so we can get into slope intercept form of the equation of the line. This one was fraction heavy too. Make sure that you keep it as fractions. If you kept it as decimals, that's fine. Next time, I want it as fractions. Any questions I can answer? The next three are just graphing. I do think that this was the 9 and 10 were the most complicated ones or the hardest ones. Would you guys agree? Some of us yes, some of us no. Okay.
Yeah, they were.
I got this.
That's half the battle. So I'm glad that you got slope. We got to remember to read all of the instructions, and that's usually more of an algebra thing. In geometry, I don't do this as much, but make sure you fully read. And if it just asks for slope, then you're good. But if it wants a full equation, make sure you keep going. All right, can I move on now? Okay. 11 and 12 are just graphing ones. Remember that when you graph, you need to go through the y-axis. It's a y-intercept, go through the y-axis. So if you graph and your graph doesn't look like mine, you probably have the wrong intercept. Most of us do great with our slope. Make sure though that if it's a positive slope, you end like positively, and if it's negative, it's going down. On both of these, I had to go like down and then a direction. So I ran out of space going up and then to the right for the first one, so I had to go down and to the left. And then for number 12, I went down and to the right to make it a negative slope. Any questions on those? The last one is another graph one, but you needed to find the equation of the line. Or if you did intercepts, that's fine too. I just have always gotten to slope-intercept form, so that's what I did. I found slope-intercept form, minus your x, divide by -1, and I got 3x minus 5, and I graphed. I like that we're correcting as we go. Any other questions I can talk about? Okay. As you're finishing, if it's on paper, make sure your name's on it, because I'm going to come get it when I look at 2-3. If it's on your iPad, make sure it's submitted. What I want you to do as we're kind of cleaning up is I want you to give me a hand. I need you to give me an idea of what's happening, okay? How did we feel about the equations, the first few problems? 1 means awful. I have no idea what's happening. This is so terrible. 5 means I am a rock star. The first. 3 means I'm feeling okay, but I need some practice. Okay. Yeah. That's fine. I can see both of them. Is everybody giving me their hands? 5 means I'm awesome. 3, 4 maybe needs a little bit more help. 1 means I have no idea what's happening. Okay, awesome. What about the slope ones, like number 5 and 6, where you had to just get it into slope intercept? How do we feel? Same scale. Okay. All right. What about the ones below that when I give you a point and a slope? Okay. 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 What about when I gave you 2 points and made you find the slope? Okay. Okay, awesome. And then what about graphing? How do we feel about graphing? Okay, awesome. Awesome. Okay, great. Okay, that gives me an idea. On iSteps, I'm trying to get more like we really know these concepts instead of me teaching you 50,000 new things that we have to like relearn every week. So you will see some more of these and then maybe another new concept or two the next time we do this. Okay, now I want the 2-3 homework out. So let's get that out. That looks like this. I'm coming to pick up your iSteps sheet if I haven't gotten it already. And you have your 2-3 homework that you are checking now. And I'm going to come check yours if you have your 2-3.
Like fighting Twitter.
No, if you already have
Sure.
So you guys already turned this in. If you already turned it in, you already have a version. So you don't need to turn it in the check version. Just for a second. You need it in newspapers or? No, I have it online. Okay. Perfect. And I'll keep it because I know I did this one. I signed it last Monday, so it maybe it's been a minute since you've looked at it. All right, let's start looking at this homework. Let's look at one, two. Now, if you switch up the order and you said that the conditional was if there's gas in the tank, then the car will run, that's not wrong, but I want us to get in the habit of just starting with how the sentence started. If the sentence started, the car will run, that's what I want your if to be. That's how I want you to start the conditional, okay? It's not an end all be all, it just is kind of helpful to me when I grade your stuff, so try and keep it in that same order. Same thing for number 2. I know it makes more sense to say if you clean your room, then you may go to the movies, but I want you to just match what you see. So I want it to be if you go to the movies, then you cleaned your room. Okay. Any questions on 1 or 2? All right. Number 3 and 4 and 5 say write the converse. If it's true, then combine them to a biconditional. So 3 and 4 I got were not true, so I don't have a biconditional. If you live in Detroit, then you live in Michigan. If you live in Michigan, then you live in Detroit. That's not true. You can live in a bunch of places in Michigan. My sister goes to the University of Michigan for law school, and that's not in Detroit, so that's a counterexample. Number 4, same idea. If 2 angles are supplementary, then they are a linear pair. They may be supplementary, meaning they add up to 180, but they may not be a linear pair. They may not be adjacent. So I have like 50 over here and 130 over here. They add to 180, but they're not next to each other. They're not adjacent. And then number 5, that is true. Both P then Q and Q then P. So I wrote a biconditional. Remember to go back to the beginning and write it from here. An angle is a right angle if and only if it measures to 90. Any questions on 1 through 5? Great. 6, 7, and 8. 7 and 6, I wanted a converse and I wanted a counterexample. You can just write one word counterexamples. You don't need full sentences as counterexamples. And you don't need 5 different examples. I just try and write as many as I can think of, so then you don't have to ask me if yours is also right. Number 8, though, it says write a biconditional of the definition of congruent angles. Well, what are congruent angles? The same. So if 2 angles are congruent, or sorry, 2 angles are congruent, if and only if they are the same. If and only if they have equal measures. If and only if their measurements are the same. Something along those lines. Questions on the front page. All right, truth tables, 9 through 10. You can write more columns than I did. You can't write less columns than I did. I did about as bare minimum as possible. So I had P and Q, which you always have. And then I know I needed not Q. Then I was ready to do all of it, P or not Q. Same thing for number 10. I did P, Q, not P. And then I did P and Q. And then I did the whole thing, which was P and Q or not P. Think about getting it as bite-sized as possible in order to have just 2 columns that you're looking at the end. So like that number 10 looks like a really long thing, but if I am just doing this column and this column, it's way easier to think about it that way. I'm like, oh, I'm just looking at the 2 columns and doing the or of them. That's not too bad. Any questions on 9 and 10? If you have trouble making the categories, please come see me because I'd love to help you. It's not that hard, and I think you just need a little bit of like one-on-one practice. So if you need help with that, let me know. Sometimes I'll give you the category, sometimes I won't, so you need to be prepared for both. Okay, can I move on? I'll just add number 11 on here. I just got rid of 9. Is that gonna cause a problem or are we cool? We should, okay. Same thing with 11. Any questions? Can I move on to 12 too? 11 and 12? The only thing about 12 is don't try to distribute the negation. Take it one piece at a time. So like here I had P and Q and not Q. Then I did P and Q. And then the next step I did the negation of P and Q. And then finally I did the whole thing all together. The brackets may look confusing, but I didn't want to put like double parentheses, so I used a different form, which is what the brackets are for. They're just like another set of parentheses. So you kept everything straight. Any other questions or thoughts on the truth tables? I'm going to scroll down so you can see 13 as well. Just your conditional, converse, contrapositive, inverse, all that fun stuff. I think you guys have gotten good at that, and we are going to do one more practice of that before we move on to today. Anything else I can talk about, or are we doing okay? If you're doing good and all done, go ahead and submit that to Schoology. It should be homework number 16. Was that right, 16? Okay. I-STEP was number 17. Most of you had that on paper. If you have this on paper, I'll come and get it from you. If you're still looking, that's fine. Take another minute. And what I want you to do is get out your 2-4 that we were working on yesterday. There's like a little tiny bit at the end. And then we're going to do 2-5. And if you want a 2-5, I'm going to pass it out now. So there's a lot going on. I'm going to pick up your 2-3 homework if you have it on paper, and I'm going to give you a paper if you want. You need to get your 2-4 homework out, or your 2-4 notes out. I need paper notes over here. So if you have your notes up from yesterday, the very bottom that we didn't do was the like it was 4 lines and it was on like that 3rd page, and we need to do the conditional and etc. forms of that. Did I get everybody's paper version? Did everybody submit their homework on Schoology if you didn't do it on paper? This is 16. So I'm going to jump over to that now. It was 2-4, and we need to do this page right here. So take a second, try it on your own. It's a nice little brain warm up for us. Just like you get warmed up in other things, got to get warmed up in math. I'll take another minute, finish these 4 statements. How long has it been loading? All right, shall we? Who can help me on the first statement? Silas? Good. If the stereo is playing, then I'm wearing headphones. I'm doing a very abbreviated version. Oh, if I could spell headphones, that'd be cool. Just to not waste your time. Okay, so that's if P then Q. What do we call that? What do we call just if P then Q? The conditional. Good, the conditional. Just the normal conditional. All right, Ava, you want to do the next one?
Yeah.
What is that?
If I am wearing headphones, then the stereo plays.
Good. If headphones, then stereo. Good. So that's Q, then P. What do we call that? Converse. Very good. All right. Who wants to help me on 3? Amanda?
If I'm not wearing headphones, the stereo is not.
Good. So if not wearing headphones, then no stereo. Very good. And then what do we call that statement if it's not Q and not P? Contrapositive. Contrapositive. Oh, where'd you go? There we go. Okay. And then number 4. Who wants to do not P and not Q? Isaac? Good. If the stereo is not playing, then I am not wearing headphones. Very good. And so what do we call that very last statement? Inverse, just straight down. Okay, so that was us just cleaning up yesterday's notes of 2.4. Why don't we go ahead and jump to 2.5? So if I gave you a paper, have that out. If you have an online version, let's jump to that. Now, little did you guys know when you woke up this morning that today was going to be a big day in math class. Today is the day that you do your very first proof of all time. Your very first proof of all time happens this minute right now. Okay. I'm sure you've heard of proofs before, right? I'm sure we've heard some not positive things about proofs. Is that right? Okay. Proofs are not meant to trip you up. Proofs are simply meant for you to tell me why are you allowed to do certain things. Now, I took several classes in college that were all proofs all the time, whole semesters of just proofs. We're only doing a few weeks of proofs, if that. So proofs are not going to be that long or intense, and we're always doing a 2-column proof. And what we're starting with today are algebraic proofs. So we're doing something that we know, algebra, solving some simple equations, and then later we'll get into the geometric proofs, okay? What we're going to start with, though, is like, what could we use in our proof? What are some reasons that I could justify why I'm proving something? So I copied a box from your textbook, and we're going to just talk about these basic properties. I know you've heard of all of them, but we don't talk about them on a regular basis, so I'm reminding us and bringing them back up. The first 4, addition property of equality, subtraction property of equality, multiplication property of equality, and division property of equality. That was a lot. Those are just your basic operations. It's just saying I'm adding this same thing to both sides. I'm minusing the same thing from both sides. I'm multiplying by the same thing on both sides, or I'm dividing by the same thing on both sides. So based on what we know about numbers, we're allowed to do those 4 basic operations. So the first 4 are just our 4 basic operations. And we're going to use these probably the most often when we solve these algebraic ones, because what we're doing to simplify an algebraic equation or to solve it is using these operations. Now, if you notice, almost all of these say property of equality. That is important. You need to have property of equality behind all of them. Now, I don't need you spending your whole sophomore year writing property of equality over and over. So what you can do is simplify it. You can either write POE, property of equality, or what I tend to write is PROP, prop, and then an equal sign. In the next few days, we're going to learn about property of congruence, and that's different than property of equality. So I need you to be able to show me that you know which one I'm talking about. Okay? So those first 4 are just our basic operations. The next 3, I also believe you know from Algebra 1. Reflexive, symmetric, and transitive. Okay? Reflexive just means that I have the same thing on both sides of the equation. Not that they equal each other, that they're literally the same thing. I think of this one like a mirror. Your reflection is in the mirror, and so the reflexive property is literally the same thing on both sides. Bless you for whoever's sneezing. You're welcome. Reflexive is like a mirror. Symmetric is like line of symmetry. Think of it like we put a line down the then, and then it flips over it. So like the B was the closest to the line, so it was written second, now it's written first. A was written first, now it's written second. I think of this like a flip. When you were in art class in elementary school, did you ever like paint half of a piece of paper and then fold the other one down, and then it was symmetrical and beautiful on both sides? Yeah, so did you ever try and make like a perfect heart out of cutting a piece of paper? So you fold it in half and then cut like the heart half on one side? Yeah, so arts and crafts, symmetry is so important. If you are not artsy craftsy, I don't really have an example for you, but think of symmetry as like we're flipping it, or it's equal on both sides, but it's flipped, it's reflected over that. And then the last one is transitive, and I actually talked about this a little bit yesterday. Transitive has 3 parts, and that's one thing I look for in transitive property. It has 3 parts, and I have a common guy in the middle. So A equals B, and B equals C. So since I've got the common guy of B in the middle, or just in general, if I have 2 things that are equal to the same one thing, then I can cross off the thing that they're both equal to and just set A and C equal to each other. The next one is substitution property, and that's just saying if A and B are equal to each other, you can replace them or substitute them in. Think about if you're substituting in sports, the whole team doesn't go off the field, right? Just like you go in for somebody else or somebody takes you off the field. Everything else stays the same, but we replace A and B with each other. And then the last one is distributive, distribute in, distribute in. That's a pretty easy one. All right, we doing okay? Let's keep rolling. Now, that's a lot of just general terms. Now let's do specific examples. So I have 8 examples, and we're going to label them with the properties. If you're feeling bold, go ahead and try it on your own. If you're like, oh, I'm not feeling bold, I need my floaties on today, then stick with me, and I'm here for you. So if measure of angle 1 equals measure of angle 2, then measure of angle 2 equals measure of angle 1. We had those, and they just flipped. They switched places. The flipping one is our symmetry. Symmetric property of equality. You could also abbreviate that SYM or something along those lines. You can cut them short as long as I know what you're talking about. The next one says if measure of angle 1 equals 90 and measure of angle 2 equals measure of angle 1, then measure of angle 2 equals 90. Oh, there's 3 parts, kind of like transitive. Let's see if transitive works. I have measure of angle 1 equals 90. I have measure of angle 2 equals measure of angle 1. Oh, my measure of angle 1's not in the middle, but it's written there twice. Each of those things are equal to measure of angle 1, so I can just set 90 and measure of angle 2 equal to each other. Now, I think first that this is transitive property, but if you also argued this was substitution, I would also believe that. I would also believe that. Substitution and transitive are kind of the only two that kind of go hand in hand. Yeah.
Do we need to memorize all of these properties?
You need to know them. Yep. So that's a great question. Memorize is kind of like a big term. Like we get scared when we say memorize, but like you just have to know them. So like if I say like write a proof, you need to know all the options. I'm not going to give you a word bank. All right. If you abbreviate substitution, make sure you don't just write SUB. I need an ST with it as well, because if you just write SUB, I could think it's subtraction as well. All right, next one says if AB equals RS and RS equals WY, then AB equals WY. We just did that, right? That should be transitive. Same idea. Again, if you argued substitution, I'm okay with that. In a second, I'm going to show you a time where we only use substitution and we can't argue transitive is fine. I'll get to that in a minute. All right, number 4, if AB equals CD, then 1/2 AB equals 1/2 CD. My original equation was AB equals CD, and I still have AB and CD. What did I put also in that equation? 1/2. What operation is that 1/2 doing? Multiplying. So I would call that a multiplication property of equality. I kept it the exact same. I just multiplied by 1/2 on both sides. Multiplication property of equality. We hanging in there? No one fell off the boat yet? I don't know why I'm on the boat analogy today, but that's what we're doing. We're in it too deep. Okay. If measure of angle 1 equals measure of angle, oh no, let me restart. If measure of angle 1 plus measure of angle 2 equals 110, and measure of angle 2 equals measure of angle 3, then measure of angle 1 plus measure of angle 3 equals 110. You good there?
Yeah.
Okay. Okay, basically, I'm starting and ending with the same thing. The only thing that's different is I take out measure of angle 2 and I put in measure of angle 3. I did not replace the entire side of an equation. I just substituted something in. This is the one that we can only use substitution and we cannot call this transitive. I did not replace the entire side. I just substituted in one piece. Just like I said, as like a teammate, if you're getting subbed in, everybody else stays on the field. Measure of angle 1 stays out there, 110 stays out there. Only measure of angle 2 got replaced with measure of angle 3. Everything else stayed in the same place. So I call that substitution. Okay. You can write POE. Yeah, that's fine. Number 6 says RS equals RS. Oh, that's really basic. Reflexive. It's itself. It's a mirror. Reflexive. Reflexive property of equality. Number 7 says if AB equals RS and TU equals WY, then AB plus TU equals RS plus WY. So it's kind of confusing. What do we think? Why do you say addition, Silas?
Because you're saying things to each other, and then you're adding them up and then making it.
Yeah, basically I added the same thing to both sides of the equation. I added on both sides of the equation. Normally they're different or they're the exact same number, but this time I was told that TU is equal to WY, so it's okay that I added both of those on each side of the equation. AB equals RS is what we started with, and then I added to both sides, so that's addition property of equality. And then the last one. If measure of angle 1 equals measure of angle 2 and measure of angle 2 equals measure of angle 3, then measure of angle 1 equals measure of angle 3. What do we think on that one? That's what? I'm okay with substitution. What else am I okay with? Transitive. Good. Those are the only two I'm okay with on that one. I'm okay with transitive on this one because you replaced an entire side of the equation. I didn't just replace one little part, I replaced the entire side of the equation. Okay? We practice those because now I'm going to use some of those properties to do my proofs. We are here. We are ready for my first algebraic proof. Are you ready? No. Okay, well, good thing I'm here to hold your hand through the, I don't know if I can say that. We'll go back. We'll just keep going. I'm here to hold your hand. Or I'm here driving the boat. You got your floaties on. I will turn the boat around if you need it. Okay, so it says we're using algebraic properties. Okay, cool. Prove that if 5x plus 1 over 2 minus 8 equals 0, then x equals 3. My given is the equation that I'm solving. I'm going to rewrite this equation right here in my given. 5x plus 1 over 2 minus 8 equals 0. And then what I'm proving is that x equals 3. It says prove that if, then x equals 3. I want to end with x equals 3. All I'm doing is solving this equation. You've solved equations like this before, but now I'm going to write a reason on why I get to do all those things as I continue on with this proof, okay? So you always start with the given. And that is your reason always in the first line is what is given to you. When you used to do textbook problems in Algebra 1, you had to write the problem down before you could solve it, right? You can't do a step and then go from there. You have to start with what's given to you. So I always start with the actual equation that's written right there, and then I write given. Now I'm going to go down my step each time and decide what I changed, and that reason is going to go on the line across from it. You do not have to draw your arrows. I'm just showing you my flow of thoughts, okay? So what changed between step 1 to step 2? I added 8. So we call that the addition property of equality. That's it. What did you do? It's probably a property of equality. Are we okay with that? Okay. What changed from step 2 to step 3? You multiplied. So multiplication property. I multiplied by 2. It is right now. It is in 2.5. It's this easy. The next one is a little misleading. Tell me what we did, and then I'll tell you what the answer is. What did you do? Did you multiply by both sides, though? Well, we just did multiply by both sides the last step. We solved. I would call this simplify. We simplified it. We took 2 times 8 and we multiplied it to get 16. So you can write combined like terms. I usually write simplify because we'll do some very obvious combined like terms later, but you can also write CLT, which means combined like terms.
So is that
Yeah, it's kind of it was just we just simplified stuff. We cleaned it up. Yeah, we just cleaned it up, made it look prettier. All right, what about from 4 to 5? What did we do? Subtraction. We subtracted 1 from both sides. Subtraction property. For simplify, I would write simplify all the way out. Oh, CLT is combined like terms. Technically, you can call it that. We'll do more that are more obvious combined like terms. So I would probably write simplify here, but combined like terms also works. All right. And then what's my very last thing I did? Division. I divided. Division property of equality. You did it. First proof done. Way to go, guys. And guess what? We're going to do another one. So flip your page over. You may not know yet what questions you have. Are we all still on the boat? Okay, some of us are holding on for dear life. We might be legs out, legs in the water. Max is the captain? Oh, shoot. Did I just get demoted?
No, no one's voting.
What's in box 6 is division property of equality. Okay, we're going to flip to the back side. We're going to do another proof. This one says prove that if negative 5 times x plus 4 equals 70, then x equals negative 18. What's given to me is my equation. Negative 5 times x plus 4 equals 70. And what we're going to prove is that x equals negative 18. We always start with the given, right? We're going to fill the whole thing in. I didn't give you any steps, but that's okay because you guys are smart and we can do it. So I have to write negative 5 times x minus or plus 4. What is happening? Equals 70 for my very first step. Oh, it told me my reason was given already. So if I wasn't sure, if I didn't remember that we always start with given, it told me I did start with given. So I had to rewrite the problem. No. Sometimes when we do geometric proofs, I give you 2 givens and sometimes we split it up, but you always start with at least 1 given. It won't do that. Good question though, Austin. Okay, let's finish this. What would I do next to solve this?
Would that be considered simplifying?
We're going to call this distribute because I am going to think about like I'm multiplying that negative 5 into the parentheses. If it said like negative 5 times x and then negative 4 times negative 5 times 4, then we would call it simplified. But this is, I have to do it all the way out. So to go here, I did my distribution. Again, you do not need to do your arrows. Sometimes it helps me though know what I'm doing. Sometimes you guys get off on your boxes and I need to make sure that you're not a box ahead. So that's why I draw the arrows. All right, what do I need to do next? Add 20 to both sides. That gives me negative 5x equals 90. So I call that the addition property of equality. Yeah.
Wait, so like
And then last is division.
would this be worth like 4 points?
There, it might be worth 7 because there's 7 blanks.
Are you gonna give us the, or are you gonna say given as the number 1?
I have to tell you, I'm going to give you either like this given or this given over here.
Okay.
And I may not give you fully empty boxes. Sometimes I'll do like that first one where I gave you all of the left side and then you just have to fill in the right side. And then my last step, I think Ben told me, was division. The biggest mistake that kids make is that they think that the last one is prove. You will never write prove in a box. Like that's just not a thing you will ever write. You'll write given, but never write prove. So if you get to the end and you want to write prove, you're not right. So don't do it. Find something else to write. Okay. We got a couple more minutes. Let's see if we can do these practice ones. Can you help me?
Yeah.
Obviously. What a great class. Yes, Austin.
If you get to the end and it's wrong.
If you get to the end and it's wrong.
Yeah, like say you're trying to prove x is equal to negative 7.
That would not be the case. So I didn't even put that in my calculator because I assumed that they knew what the answer was. So I was like, I know I had to divide. I assume the answer is negative 18.
Oh, so like the proof will actually go do that?
It should be the right answer. Yeah, it wouldn't be a wrong answer.
Okay.
Okay, who knows what number 1 should be? Who knows? I have 1, 2. Who else knows? 3, 4,
Oh,
5. Cece, what's this one? Symmetric property. Awesome.
yeah, that's
Why is it symmetric property, Cece? You flipped it. Very good. So I flipped it, so B goes first now. Let's just do the same column. Who knows what 3 is? 1, 2, 3, 4, 5, 6. Bam. Reflexive. Good. That's fine. Symmetric. Let's do the last 2 and then I'll clean your desks. Who knows what number 5 is? Think about it.
The thing.
Who thinks they know?
Hold
What'd you do?
on. Oh, is it a-
I have 1, 2, 3. Maggie, what do you think it is? I think you're right, Maggie. Why? You're essentially, Van, can you explain it?
because we added YZ. And so
When you add YZ to the left side, it gets it just XY, and then you add it to the other side. It's true. What'd you say? Anyone? Are you guys talking to me?
Oh, no.
Okay, that's fine.
She said the thing she said.
We don't use stupid in this class.
Okay.
I don't know why we think that's okay.
My bad.
Yes, I'm sorry. Okay, what's the last one? I gotta clean your desk. What is this one? Who knows?
That is,
Pay attention, last one. If measure of angle A plus measure of angle B equals 90 and measure of angle A equals 30, then 30 plus measure of angle B equals 90. Who thinks they know? I have 1, I have 2, I have 3, I have 4. I have Megan, what is it? Substitution. Why is this one not transitive? Good. That is a common mistake we make. That's why I'm glad Megan got it right. I'm replacing measure of angle A with 30. I'm not replacing an entire side. We'll look at the other 4 at the beginning of class next time and finish these notes, and then we will review. Let me stop my recording.